mathematics. So today we will be solving one question where a train is given to you. Okay, a train is given to you, and the velocity of the train increases at a constant rate alpha from 0 to v and then remains constant. That means if this will be the number line, okay, if this will be the number line, then in this question it's given that from 0 to v, that means let's say this is v. So from 0 to v it's increases, right? It's given that the velocity of a train increases at a constant rate alpha from 0 to v, right? So and after that it remains constant like this, right? It remains constant, and then it's fine now. And then what happens? And then remains constant for an interval and finally decreases to 0 at a constant rate beta, and after that it decreases here like this, okay, and then stops, right? So let's say this is the axis of y axis is the axis of velocity, right? This is the axis of velocity, and here if it's time, right? Then you can see from O to a certain distance, right? Which distance? Let's say it's A, and from A to B, this is the timing. Then on the x-axis parallel to A is B, and let's say it's C, and from here is C, parallel to C is D, and here it's E, right? Now, in this question is given that the velocity of a train increases at a constant rate alpha. So, velocity increases at constant rate alpha, right? Which period is this? This is the period from O to A, right? During this period, the velocity of the train increases at a constant rate alpha, right? Then it just runs constant at a constant distance. You can see A to C. Then gradually it decreases at a constant rate beta. So for OA, the rate of increase is alpha. For OA, rate of increase is alpha. So the rate will be given by you as, if this is AB and this is OB, right? Then rate will be tan alpha, that is AB by OB, and that value is given to you as alpha, right? So that rate can be written as, for the distance O to A, for O to A, we can write it as alpha is AB by OB, right? Because into the question it's given that the velocity of a train increases at a constant rate alpha from 0 to v, and A is the point where it attains a velocity of v, you can see, right? So this velocity v is attained at a distance. So from when the train starts traveling from O, then from O to A, that means O is equal to 0 over here in the number line you can see. Then O to A, the train's speed is gradually increasing. Okay. Then when it reaches a position of A, it attains a constant velocity. Then you can see when after B, this is the time interval on x-axis. When the after B, when the time is increasing, the train is at same velocity v, right? At this point also train is at v. At this point also train is at v. So from A to C, the train is traveling at a constant speed, right? And the time taken is B to D, right? The time taken by train from for the constant portion, that is A to C, is BD, right? Since we have calculated the acceleration point, okay, and for the deceleration, that is from C to E, let us calculate that. I mean to say the section C to E, then we will come to AC, right? So for the section CE, it's given that it decreases, okay, at a constant rate beta. So similarly, CD by DE will be the rate of decrease for CE. So for the section CE, we can write what? Beta, as given into the question, you can see beta is the rate of retardation. Okay. So this is given by CD by DE. Right? So this portion is calculated and this portion is calculated. So I am reading the question again as given into the thumbnail also. The velocity of a train increases at a constant rate alpha from 0 to v, this portion, right? Then remains constant for an interval. So this will be the portion of constant interval A to C. This is constant interval, that means from A to C, this one, right? And from and finally decreases to 0 at a constant rate beta. Okay, so this is the from C to E is decreases, right? If x be the total distance covered by the particle, so the total distance which is covered by the particle, I mean to say the train, okay, is x. So the another data is given into this numerical is x is equal to total distance covered, right? Total distance covered is x. Okay. Now we need to find the total time taken t. The total time taken t is given as equal to x by v plus v by 2. This we need to prove. Okay. We'll see how we will be coming to this figure. 1 by alpha plus 1 by beta. So this is the requirement that the time interval for the entire duration of this travel is equal to x by v plus v by 2, 1 by alpha, 1 by beta. Okay, this will be in the product as you are seeing over here, right? So this we need to prove. Students, you know that this is a velocity time graph. This is a velocity time graph, and for the velocity time graph, what will be the area which is covered under the velocity time graph that will give you the distance covered by the train, isn't it? The area which is covered by the velocity under the velocity time graph will give you the distance covered by that train. Okay, so what will be the area covered by this velocity time graph? From O to A, it's A to C and C to E. and this is looking like a trapezium, isn't it? You can see this is looking like a trapezium, and the area covered under this trapezium, this area will give you the total distance, right? So what we will do, we will calculate the area covered under this trapezium. This will give you the total distance covered. Okay. From that, we will find out this time interval. Okay. So we will work on this agenda and let's proceed. Automatically, this value will be coming to you, this time interval. Right. Now, let us start now. Here you have already calculated for O to A. What is the value of for O to A, the acceleration distance alpha equal to AB by OB. Okay, because it's the rate of acceleration given to you into the numerical, and beta is the rate of retardation given to you from to C to E, that is CD by DE, that is given to you. Okay, now the for the portion A to C, for the portion A to C, what is the value? We will find it out. Okay, now coming to the area under the velocity time graph OACE. Okay, so we will be calculating the area. Area of, so let me take another paper so that it will be better. So we will be calculating the area under the graph OACE. So the area of the, let's say, trapezium OACE, right? OA. Hi Janely Cubes. Hi, hello. Which language is that? It's English. Is it? Are you not able to understand? Right? This is the area of trapezium OACE, which we are going to calculate. Right? Hi Janely. It's English. I hope you understand it. Now, area under the graph OACE is given to you as, you can see, OE. It's a trapezium. It's a trapezium, you can see. This entire figure is a trapezium. We will calculate that area. Okay. So the area of the trapezium is equal to half of sum of parallel sides. That means these OE and AC are parallel sides. So we can say OA plus CE, OE plus AC, OE plus AC. OE and AC are two parallel sides, you can see, right? And this multiplied with the distance between them, that is AB. AB or CD, the both of this is equal to V, you can see. You can see over here, AB on the y-axis, you can see it's V. Okay? Into AB. This is the area of this trapezium, which I have said it. Now, we just put up the value half. So all this area is your distance, and that is given to you as what? X. That X is given to you. you can read the question properly. It's given that the area, the distance covered is x, okay, and that distance is given by the velocity time graph and the area under it, right? So this is equal to half into what is the value of OE? OE is OB plus BD plus DE. You can see three sections, this, and this, right? So OE can be written as OB plus BD plus DE, right? OB plus BD plus DE. I mean to say O to B, then B to D, then D to E, right? These three portions. Just this will give you the value of OE, right? This will give you the value of OE, right? Now, plus the value of AC. So AC can be said it's equal to BD, isn't it? AC is equal to BD. So write the value of AC as BD so that you can see 2 times BD will be coming to you, right? Now, the bracket will be closed, multiplied by AB. What is the value of AB? It's equal to V, isn't it? This is AB. From B to reach A, what is the value of printed on the y-axis? It's V. So just put up the value of V. In place of AB, the value of AB, the value of AB is V. You can see, right? Now, just we will put up the values over here, okay? So the value of OB we have already calculated. OB alpha is AB by OB. So OB can be written as AB by alpha, isn't it? AB by alpha. So OB is given as AB by alpha. So from here we are writing, changing the pen so that it's easily distinguishable. OB is AB by alpha. From here you can see OB is AB by alpha. AB is this one. So AB and AB is V. So it's given as OB, this OB is given as V by alpha, isn't it? It's given as V by alpha. This value of OB is given as V by alpha plus 2 times BD, right? This BD plus this BD, 2 times BD, right? Plus DE, DE. So from again here you can see, from here DE can be said as CD by beta. DE when goes into the LHS, this will give you CD by beta. And what is the value of CD by beta? It's CD is equal to AB is equal to V. So it will give you V by beta, right? So the value over here is V by beta for DE, right? And all this will be multiplied with AB. And what is the value of AB? It's V. It's V, right? And all this is equal to X, okay? X in the LHS. Now, Just solve it to get the value of BD. Okay. Now, just do a simple calculation. Okay. I'm just squeezing the window a little. So this will give you 2x. 2x is equal to V by alpha plus 2BD plus V by beta. Okay. So V from the RHS can be taken into the LHS. So this will give you 2x by V, right? And into the RHS, we are left with what? V by alpha and V by beta, right? So just write V by alpha, right? V by alpha plus 2BD plus V by beta, right? Onto the next line, we can write 2x by V. Just find out the value of BD. So keep BD into one of the side so that other terms will be going onto the one side of the equation, right? So this will give you 2V. This will give you 2V by 2x by V. This one 2x by V, 2x by V minus V by alpha minus V by beta, right, is equal to BD, and these two will be coming into the LHS. Okay, so this will be coming as, this is 2BD. Okay, just write it as it is. Okay, now the value of BD can be written as, the value of BD can be written as 1 by 2, 1 by 2, 2x by V, this one, minus V by alpha minus V by beta, isn't it? So this is the value of BD which is derived, right? That means BD is this one which is equal to AC. This is the same portion. From A to C, it's B to D. Both are equal. So the length of BD we have derived, it's half 2x by V minus V by alpha minus V by beta, right? Now, the total time taken, the total time taken from here to here is OB plus BD plus DE. Now let us write the total time. Total time is O to B and then B to D, then D to E, right? You can see this is a time graph. X axis is just used for time, locating the time. So OB plus BD plus DE time, total time is given by T is equal to what? OB plus BD plus DE is given by OB plus BD plus DE, right? Because all these three values will add up to give you the value of total time O to B, B to D and D to E, right? This is the total time. And we have already calculated the value of BD. What is BD? BD is the constant interval, the interval for which the train runs constant or which is equal to AC, right? Now, just put up the value of T over here, okay? Because in the derivation we need to calculate the value of T, right? So from here, changing the pen, okay, T can be written as, from here, T can be written as OB. What is the value of OB? We have already calculated, it's V by alpha. OB is V by alpha, you can see from here, and also from here. AB is V, so it's written as V by OB, right? So OB is V by alpha from here. We have already used the same relation above, okay? So OB is V by alpha. Put up the value of this, V by alpha. OB is V by alpha plus BD. What is the value of BD? Don't worry, we have already derived it, okay? The value of BD is derived over here. Just put up this value, half of what? 2x by V minus V by alpha minus V by beta. Isn't it the value of BD? So just put up the value of BD. And the value of DE. The value of DE, as we have calculated V by beta. Here from here, CD is V. So V by DE. Beta is V by DE. So DE is V by beta. Okay. So it will be coming as V by beta, right? So we have almost arrived to our answer, okay? So let us see. So from here, just it's a simple calculation, just follow the same, okay? So since T equal to V by alpha plus 1 by 2 2x by V, so just arrange the like term, V by alpha, and here you can see minus V by alpha half times. So just write it, V by alpha, changing the pen over here, V by alpha, this one, this term, minus half times V by alpha. So finally this will be coming as only V by half V alpha, V by alpha, right? Plus 1 by 2 V by beta minus 1 minus V by beta, this term, right? So we can write plus V by beta, the last term, minus half of V by beta, this one, right? Plus 2 will be cancelled out and x by V will be remaining, x by V, right? This will give you x by V, just bringing into the front x by V, this last term, this one, x by V, V by alpha minus half V by alpha, this will be giving you half V by alpha, right? and v by beta minus half v by beta, this will give you minus half v by beta. Taking half as common, it will be looking like this, right? And there will be a plus sign because v by beta minus half v by beta will be v by beta. So this is the value of time period of the traveling of this train for this entire duration. Okay, and this we have derived it now. Okay, so this is your answer. Okay, students, if you find it useful, you can just like. Thank you so much for watching. Bye bye.